Hey guys, welcome back to the shop. If you don't know who I am, my name is Adam and I'm a machinist. So this is Saturday night special and I always try to bring you some interesting content every week. So hopefully this week is no different. So I get some machining done this week in my shop, and what I've got for you is the threading. I machined the new Acme threaded nut for the tool head on the Genie shaper, and I've got all that footage to share with you. All right, I'm going to go ahead and tell you that I'm going to have a follow-up video after this SNS with some more Acme thread cutting, because after I finished the first one, I kind of sat on it a couple days and I just wasn't 100% happy with how it turned out. It was going to work fine, but I wanted to give it another shot, so that's what I did. So I've got another video that's got more of the same kind of content, maybe a few different camera angles, and so the second one I think did turn out better because I learned what mistakes I made on the first one, and I corrected those and made another one. That's why I bought extra material, so that in case that happened. So anyway, that's what you're going to see this week. And I went ahead and I'm kind of started on the clapper box I got sitting right here. I started doing some of the cleaning up and polishing and filing and stuff on the clapper. And this weekend I'm actually going to get started on the clapper box itself, just getting it dressed and cleaned up. There's lots of hammer marks all over this thing where people hit it whenever they go to slide it back and forth. That thing would just get hit. So that's what I'm working on now, but we got lots of little things that we need to get done as far as the tool head goes. We've got that bevel gear that was missing the key inside of it that drives the lead screw. Still got to fix that, and I still got to get all the parts just kind of cleaned up, deburred, filed, and Scotch-Brighted, and get it all polished and put back together. So lots of little things, and I'm going to bring that footage to you every week. I'm going to be out here getting something done, and that's what's going to be seen in SNS, okay? All right, so that's what's going on right there. There is the two nuts. This is the one that we're going to make tonight on this SNS, and this is the extra one that showed up last week whenever Tim sent all of the spare parts off the 24-inch. And I had a lot of guys ask about this, is this one any good? Did I measure it, whatnot? I didn't actually do any backlash checking on this, but it feels just like the other. You can screw this onto the other lead screw, and it's got wiggle around. I can see it moving back and forth. And this one is shop made. Somebody has remade this over the years, okay? So it'll work, but it's not going to be any better than the one that I took out right there. So we're going to make another one. All right. So I hope you guys are continuing to enjoy that content. It's been a great project here for the shop because it's providing a lot of good content to share with you guys, and I just try to grab the camera and show you whatever I get into, okay? I've got a couple quick things here to share with you. I had mentioned that I ordered a new Acme thread pitch gauge. I ordered this through KBC Tools. I had emailed Chris Brown and showed him the one that I was looking for, which is this guy right here. It's the SPI brand. Swiss Precision Instruments, I believe, is SPI. So they may not list some SPI stuff in their catalog, but they can definitely sell it to you if that's what you're wanting. So they ordered me up one and sent it to me. So now I have my very own high quality Acme pitch gauge here in the shop, okay? So good tool to have around here. And I've been kind of enjoying this Acme thread stuff, and I mentioned in the video it's been a while since I've done any, and so it's kind of like you don't do it all the time. You kind of got to get your practice back up and remember everything. So it's been a good learning lesson. All right, I've got a really nice little gift right here that was sent in to me by Jim Stamper, and he has got a 3D print of my logo here. And Jim Stamper, he's from Vancouver, Canada, and he wrote me a nice letter and was telling me that he has been getting pretty heavily into the 3D printing world, and he's got like 4 machines now, and gave me some tips on some different people that I can look up on YouTube as far as the 3D printing content. And I was going to mention, because I did mention before that I'd thought about maybe getting a 3D printer, and I was going to mention that I have And I am in talks with somebody right now about a 3D printer, but there's nothing 100% yet. So we're still kind of in the talking phases of that. But I am trying to get a high quality 3D printer. I don't want just a little cheapo in here. I'd like to have something high quality. So that's what I'm dealing with right now. And as that develops and something comes out of that, I'll be sure to let you guys know. And I'm hoping that I have a nice little 3D printer that I can set up right here next to the computer and start making my own little projects around here, you know. So hopefully that's going to be some more content to share with you here in the future. I want to show you just the cutest little viewer gift that's come in this week. So I've always wanted a Stand Ridge granite plate ever since I got to tour the factory a couple years ago at the Bar Z Bash. I've always wanted one of the granite plates, and wouldn't you know, I finally have one. And it even come with its own certification. Look at that. A certified granite plate from Stand Ridge. So this is a nice little gift from Tom Lipton over at Ox Tools. If you don't know Tom Lipton, go to this channel right here, Ox Tool Co. on YouTube. I'm proud to say that I consider myself a good friend to Tom, and he is an absolute wealth of knowledge and just a joy to communicate with, email with, and you know, every now and then I have something that stumps me at work, and I'll send him a little email, and he always has an answer for me, you know. And I'm just so thankful that I have friends like that, like Tom. But he is very, very into you know, metrology, especially right now. He's showing lots of different metrology type applications and tooling and just all kind of stuff involved around metrology and fixturing and lapping and surface finishes and tolerances and things like that over on his channel. And this is the second batch of these little baby granite surface plates that he has had made up from Stand Ridge, and he was nice enough to send me one. I missed out on the first batch, and when he had announced that he was going to have a second batch, I asked him to put my name in the hat, and one showed up. So these are 2-inch by 3-inch by 1-inch stick with the 2 ledges. And Tom says that these actually are pretty useful on granite plates and also surface plates, you know. Now I don't do any surface grinding around here, so I'm not as knowledgeable with that type of work as he and some of the other guys out there on YouTube, but he has developed some pretty good uses for these little miniature granite plates right there, and talks about it over on his channel. But it's just really neat that Stand Ridge actually, you know, laps these things in. It's a grade A inspection grade, good to 1/10. So very cool. Thank you very much, Tom. This is really nice. It's got the calibration dates there on the back and when it's due again. Very cool. Nice gift, Tom. Thank you very much. I really appreciate it, and yeah, thank you for sending it to me. All right, it's time to get this new nut machined in. There's our sample. Here's our new piece of stock right here. We're going to use our new 3-jaw chuck to hold this, and what we're going to do is do most of the machining here on the Victor. We'll get it turned, we'll face it, turn it, it'll be rough board, and we'll part it off, and then we're going to go to the Monarch lathe to do our threading. Once we set it up in the Monarch, I'll finish the bore out to the proper size, that way it's true with the OD, and then we'll cut our threads over there too. Our length for our sample is 3 1/16. Well, they love them 16ths, don't they? So we're going to hang it out about 3.5 inches, just a smidge over right there, and that'll give us enough room to get our parting tool in there close to the chuck jaws and part that thing off. Alright, let's see how it's running. Not bad. Okay. So I think our choice of tool today is going to be old school, like everything else we're doing. Brazed on tool bit. carbide brazing on tool bit. I don't know what brand this is, just says USA on it. And we'll go ahead and face it with that and do our turning. Let's get her faced and drilled first. What we're going to do is get it crunked up here. I want to check my center height. I eyeballed it with the live center. Looks like it's just a few thou low. Alright, let's go ahead and get her faced off. So again, this is ductile iron. It's just like cast iron. It's like ductile. It's got a little bit tighter grain structure to it, and it puts off a nicer chip, leaves a better finish. And those old brazed on tool bits are a perfect tool for cutting this ductile iron. I'm going to use this fresh 25-30 seconds drill bit to make a pilot hole through there. And I'm just going to go all the way to the very end of the flute right there with it. Nice sharp drill bit that's got a factory grind on it. And then we're going to finish it out with a 13/16 drill bit, and that'll be our rough bore. You do have to clear your tips, keep your ways nice and lubed, and you don't have to crank it in and out. You just loosen your handle and just slide it in and out, clear your chips. Alright, we got our 13/16 taper shank drill bit. We just put a fresh grind on that thing, like factory new, sharp as a razor blade. I'm about to start the turning. What I'm pointing out right here is I got me a stop set with my dial, and it's always a good idea to check rotation before you actually spin the chuck up, just because you are very close right there, but we are going to clear it. Alright, I got the speed set at 160 RPM, and let's see how that does. We don't have to, we only got really about 100 thousandths to come off of this. So I'm going to make a couple of cuts, and we'll bring in, we'll sneak up on our size. We'll go ahead and give it a mic. Should be around, somewhere around 1.550. We're at 551. So we got exactly 50 thousandths that we want to take off this thing. I'm going to go verify the bore, but I'm like the old nut right here that come out of the tool head, and this measures 1.501 inches right here. So let's go snap a measurement inside the bore and see, and we'll see the difference between the two. Here's our bore where the nut is going to go in there, making sure there's no dust in it. Alright, let's see what it's measuring. It's So that is saying 2/1000 over. See if I can get a little further back, see if it changes back there. All right, looks like one over in the back there, so may have a little bit of a stretched hole right there. Tell you what, I'm gonna do one more. Yeah, 2/1000 right there. So may have a little bit of a tapered hole in there, but we're gonna make it a snug fit, just like this one was. And we'll just make ours about the same, about 1/1000 over. All right, so we raised the speed, we're on at 370, and I slowed the feed rate down. Try to get a little better finish there, and we'll go ahead and just sneak up on our size. So we had 50/1000 to come off after that first cut. I took 25/1000, and that puts us at 526 exactly. So we have exactly 25/1000 to where we want to finish it at. 25, so I'm going to try to hit my size. We're going to dial in 24 to try to give me at least 1/1000 to polish it in. That may be about a half a thou less than that, so we got an undercut on this end, so I'll tell you what we'll do. We'll go ahead and stop it. And let's see what I hit. Look at that. We're at 1 4/10. Perfect. It's right where we want it. We'll go ahead and turn that undercut here on the end. It's approximately 3/8 back, and I don't need to take it as deep as they did. I looked down inside that board. There's no kind of relief needed to clear down here on the end, so I'm just going to take like 10/1000, and that'll help us start that nut down in that hole. All right, and that's it. I'm going to do some chamfering and some polishing. Got it right where we want it, 501. Okay, we're gonna see if we got enough material here. We're gonna part it off with 1/16 long, and yeah, we got plenty right there. Okay, so I'm just gonna eyeball measure the length, 3.125 inches, and I'm within 5/1000 of an inch right there. We will verify that. I better double check before I spout off being that close. All right. 3.125 inches plus or minus 5/1000. How about that? We'll check that and see with calipers. Got us a catcher rod right here, and let's do it. Now I'm probably going to hand feed this. I have a lot of guys that ask me that. Really just depends on what I'm doing. I like to feel that tool because sometimes the chip tries to weld to it. Now before we get it all the way off, I'm going to just break that corner off so it's not razor sharp. Let's measure with the calipers to see how close I got it. Okay, here we go. 3.120. Well, I was within my range. I said plus or minus 5 thousandths, so 3 inch 120. So as I said, you can scale within 10 thousandths. So this guy is ready to go to the Monarch lathe. Let's go ahead and get this thing set up in the Monarch here, and we're going to get it bored and threaded. So I've already preset the forge jaw, and what I want to do is I want to leave it out enough where I can see the back end of this nut right here. And by the way, I pre-measured it, so you know I know how much I need to face off this to bring it down to 3 1/16, and that's not that critical really. We're just going to make it an even 3 1/16 wide, and I can see the back of the nut right there. Now I'm just holding it with these chuck jaws. I don't want to mar it, so I'm just holding it is all I'm doing. And what I want to do is, well, I was going to use these. They're a little bit long. Let me go make up some shorter ones. We're going to use these shims to keep the jaws from biting into it. So I'll be right back. I'm going to make some more. All right, I just took 2 of them and used my little shears and cut them in half. And looks like that's going to work out real good right there. All right. Just use our tool post indicator here. You want to be careful not to over squeeze it, but it's got to be tight enough so that the pressure of that tool bit cutting isn't going to try to make it slip or move. We're just about there. About 1 thousandths. Alright, that's less than 1/2 thou right there. Looks like it's going to be good and eccentric there. Looks like it's going to be good and concentric. Got the same amount of movement there as you do further back. Alright. We'll start with our face. Just touch. We're going to take 58 off of that. Get our chamfer on there. Now we can go ahead and get our bore to size. I've got a carbide shank bore and bar set up. This takes a TPG insert. These are excellent inserts for any kind of ductile, cast iron, or bronze. We're going to use that. We're going to get this bore to our size, which is going to be 0.862. And here we go. I need to change feed directions. We're going to touch off and take 20 thousandths. That tool bit did a beautiful job on that. It's always a good choice for this kind of material, that TPG. Okay, so I'm at 845. Alright, just verifying the math. Make sure I'm not wrong. I'm at 17 thousandths to come out, so we'll take one last cut. That was my final cut right there, so let me see if I hit my size the way I wanted. Look at that, man. Looks like 862 and a half. Right at 863. Well, we're there. All right. We need to put a chamfer, and man, it's going to be difficult to get that back one. We may have to do that afterwards. All right, let's go ahead and get that one chamfered. Getting the compound set up to do our internal threading, so we're going to be swinging it to the left for our infeed. So we got her loose, and what we want to put it on is 14.5 degrees. The divisions on these old machines like this are very, very accurate, so you can trust putting it on what you want and it's going to get you there. And what's nice is that on the Monarch you have one on each side, so you can look at this side or over here and verify it, you know. So that looks pretty good, but I'm gonna move the camera and get in there and verify them at 14.5. But it looks like we're right there. So I want to make sure that my tool holder and tool post is square. Alright, I think that's good enough right there. So this is a V-block that I made years ago that is able to hold these smaller bars and get them up on center height. So we got that sitting on that, and I'm going to be pulling the bar directly up against the tool holder. Giving myself a little bit of run out room, so we got the tool coming out past the end of the nut here. One thing you can do to try to make sure that your tool bit is level in these tool holders here is to stick a tool bit in there, a long one. That way you can look at it and really see where it's pointing at, and you can put a level on here also. It's looking pretty good right there. I'm just eyeballing this, and that's looking pretty good. So on these Monarchs you have this thread stop that you can engage. This is a little stop feature, and I've got it dropped in. Alright, so when I retract, that's going to be retract, you know, bring the tool out, crank the carriage back, and then we want to come back to our zero. I'm holding this in because it is a little bit of weak on the backstroke. It tries to come by it sometimes. If you hit it too hard, it'll try to push it out. So You just come back nice and gentle, and it'll always come back to 0 the same exact time, because you have a positive stop built in down here. So we got this set. Now we need to set our compound. So all of my infeed is going to be used with the compound right here. We got to set our 14.5 so it will follow the shape of the thread. So each pass, including the touch off, we're going to come in here. We're going to come in there and we're going to touch off and zero this out, and we're going to get started threading. I've already got the tool touched off. I've got to crank back here so we don't go into it, but I'm going to go ahead and engage the half nuts here, and I'm going to show you. All right, we've got it, we're engaged. All right, we're moving at 5 threads per inch, and this lever right here, once I'm through there, I can pull it up. That puts it in neutral. Bring it all the way up, and it's going to bring that back. You don't have to disengage the half nuts if you don't want to. That's one of the cool features about this machine. When you come back, you put it in neutral, go all the way down to feed forward again. You can also bring the stop collars down here. There's a lock collar down here. All right, you can tighten this up. There's one on the other side as well. So this thing it'll kick into neutral. Let me see if I can hold it. Now, if you tighten that up, it'll actually push that down in the neutral, so it'll just stay in that one area. I'm not really going to worry about that. We're just going to do it like I normally do. I just wanted to show that. It's one of the cool things about Monarch. All right, we're ready to make our scratch pass and see if we're correct on our dial there. Okay, we got our Acme thread gauge here, and it looks like we're spot on, guys. I'll take a picture so you can see it. You can see what I'm looking at right here. All right, we're good. So we're going to bring it back to 0, and let's take a better cut than that now. Let's go 20 thousandths on the dial. Yeah, man, that's looking good. All right, 0. Let's take another 20 thou. All I can do is just keep making my passes through there and hope that we end up where we want to be. I'm getting really close, and I had to tweak the grind of my tool, and I was getting a little bit of rubbing underneath here. So I went over there to the grinder without taking this tool bit out and was able to grind the bottom of that, and now it doesn't seem to be rubbing like it was. I'm going to make a spring pass through there, and it's doing much better now. We're getting real close. Now it's got a really good smooth shearing action to it. We are just about there. Look at this. It's going in, but it keeps getting tight on me. I got some coral sprayed up in there and it loosened it up for me. I think there's just not enough clearance yet, but it's trying to go. I was probably, I don't know, a good quarter ways in there. I need to make another pass. Well, we finally got the screw through the nut. The very bottom end is actually a lot tighter than the top end up here. So I went ahead and screwed it in there, and I'm trying to see what my backlash is up here on the front. And I keep getting about 3/1000ths. Looks like we got about 3/1000ths backlash. Once I got it through the tight spot on the back end, I was able to screw it in there. So it's good on this end right here. All right, that's the back end of the screw we're going through now. Evidently that very last thread and the very end of the thread of the rod is a little bit tight. And once you get it past that, right there, it goes on in there. So it did more of what I was afraid it was going to do, which is once it finally screwed in there, then it was going to appear to be more loose. You can see it's rocking a little bit. I was really trying to get a lot tighter fit than that, but this is what I ended up with, and I think it's going to be an improvement of what was in there. So I'm not going to take any more out of it. There's the back side. You can see the backside thread looks absolutely gorgeous. The side that I cut was actually rubbing a little bit more. So I think this very last thread is where it's binding up. You can see it's kind of shiny right there on that last thread as it's trying to exit. And that's something that I have experienced before with the threading tool. As it's retracting, it's coming out, the tool not cutting there, it seems like the carriage is being pushed out faster than what it should be, and it creates a tight spot on that last thread. But you can see we've got a razor edge there, a burr. So we're going to go to the 3-jaw over here and see about chamfering this side, and then we'll see if we can do some backlash checking on the nut like we did before. So we're going to check the backlash. Now, if you watched SNS 209, I did this check on that episode, and I was showing the different backlash. I believe I was getting somewhere between 7 to 11,000ths backlash, depending on where this nut was. And I also showed that down here in this general area, there was a little bit of a crook in this screw, not just a bend, but like twisted. Okay, and that's why I didn't want to mess with even trying to chase this thing. All right, so let me just come back here. So just to try to turn this nut by hand is a little bit difficult, and I'm actually having to hold the nut. You see I can get it, but it's That's that bendy area. Just a few thousandths is making that get snug in there. Okay, so I just ran this past this because it's very unlikely that I'll have, well, once all this is together, I'll be able to move it with the hand wheel, okay? But it's highly unlikely that I'll have this screw run so far up that it's going to be up in this nut whenever it's being used on the machine. So we're going to come down here to our indicator, and I'll move you closer so you can see. There it is. 2 thousandths right there. I'm getting 2 thousandths. Just show you this spot before we move it. All right, 2 thousandths. So let's move this down. All right, this is going to be, see, it got a little bit loose right there. So this general area, there was just a little bit of the keyway showing. Three thousandths, 3.5, okay. 3 to 3.5. That's what I got right there. So that is that's a much better improvement over what was in there. So I think between this and the thrust bearings on the end right here, we're going to be good to go. Just one more check. We're down here on the other end, and I'm getting 2 thousandths. 2 thousandths backlash. I'm going to call that a success on a threaded Acme nut right there. Alright guys, we got it done. There it is. There's the old one. And it works. Very happy that it works. I really like this side right there, man. It just looks absolutely beautiful. And that's going to be the side, I believe that's the side that's going to be taking a lot of the thrust as whenever you're feeding it down right there. It turned out real good. I'm happy with it. So next phase is to actually install it into the tool head, which I don't want to do that yet because I want to finish getting that thing cleaned up real nice, get it polished, get it deburred, and then we'll start the rebuild process, okay? But I'm real glad that this is finally done right here, and I think this is going to help our backlash and our in-play problems that we were having with the screw right here. So we're making headway, guys. We got our sails set and we're well on our way.